Now we're going to look at solving word problems where there may be more than one quantity in the problem. There might be two unknowns, but there will be some kind of relationship between them. And so you'll be able to represent one quantity with an X, and then the other quantity would be represented using an expression involving X as well, okay? So here's the example to start with. If you know that one number is 5 more than another number, then you can let X be the first number. The first number. Okay, so let the first number be represented with X. Okay, the first number I'm going to call X. Okay, then the second number, it tells me, is 5 more than that. 5 more than that means I could use X plus 5 to represent it. Okay, so like if one number was 2, I'd want the other number to be 7. So it's 5 more than that. Okay, so we're going to be working through a few problems where we need that skill. So let's try another one where we're just trying to represent a quantity. So for instance, Donna, we know, is 5 inches taller than Christina. So if we're going to let Christina's height be given by X, okay, and we want an expression for Donna's height, we don't have to use Y or some other variable because it's related to Christina's. We know she's 5 inches taller than Christina, so Donna's height could be represented with X plus 5. Okay. All right, here we have one where John's test grade is 5 points less than twice Ariana's test grade. So if we're thinking about Ariana's grade, and if we let X represent her grade, then we could get an expression for John's grade. We wouldn't have to use Y. What we could do, it's related to Ariana's grade. So all we got to do is translate this phrase. We know his grade is 5 points less than twice her grade. So we're going to do it like we did earlier. Her test grade is what we're calling X. So back up and hit an operation word. You need twice that. So X is Ariana's grade. We need twice that. And then continue backing up. We need 5 points less than that. So twice that minus 5. So his grade could be represented in terms of her grade. So X is her grade. Then, so like if she made a 60, let's say she had a 60, then he would have done 120 minus 5, that would have been 115 for his grade. Okay, so let's use that on these problems. And I just noticed that my numbering somehow got weird. So 16, 17, this would be 18 and 19. Let me just renumber them while I'm thinking about it. Okay. All right, so here's a problem, number 17. A carpenter is going to cut a board into 2 pieces. So here's the board I'm trying to cut. Anytime I can draw a diagram, I do. I don't want to put where my cut's going to be yet till I read a little further. But I do know that the board is, let me give myself a little more room. So here's my board. Okay. Oh, why are you doing that? Here's the board. Okay. And I do know the length of the board is 6 feet. Now, as I read, it says one piece must be 3 times as long as the other piece. So I don't want to draw my cut right in the middle. So I'm going to show a cut off to one side. And this may not turn out to be exactly to scale. But I know one piece, at this point I know it's longer than the other, and they want me to find the length of each piece. So why don't I let X represent the shorter piece? Let me write shorter piece. I'm going to let be X. The other piece would have to be 3 times as long as that. So wouldn't the longer piece have to be 3 times that? So this piece would be 3 times that. But then I've got to be the one to see where an equation could come from. So that's where the diagram helps, because I'm cutting a 6-foot board. So it should be that if I add the length of the shorter piece to the length of the longer piece, I should wind up with 6 feet all total. Now that X is really an understood 1X, so I have that 4X equals 6. And when I divide by 4 on that, I'm going to wind up with X equaling 1 1/2, 3/2, which is the same as 1 1/2 or 1.5. And since the 6 was in feet, that would be 1.5 feet. So the shorter piece would equal the 1.5 feet. So that means the longer piece would equal 3 times that, which would equal 4.5 feet. And on questions like that, watch out. They might just ask you for the longer piece. And if they did that, you'd have to know not to put in 1.5, but to wait until you do 3 times it, because the longer piece would be 4.5 feet. And then if it asks you for both parts, just make sure you put the correct one in the correct spot. Shorter piece, 1.5, longer piece, 4.5 feet. Okay. All right, here's another one that I pulled out of Alex. Pat and Ron are planning to build a deck. They buy some plans. The plans can be customized to the required deck height, which is 92 inches. They call for support posts of 2 different heights. The taller ones are 8 inches longer than the shorter ones, and the plans say that the sum of the lengths should equal the height of the deck. How long should the support posts be cut? Okay. So I think this is the key sentence right here. We know we're going to have support posts of different lengths. So let's let X equal the shorter, and let's let, or the shorter one we'll call X. We'll have a length of X, and then we'll see what we get for the taller ones. All right, so it says the taller ones are 8 inches longer than the shorter ones. So the taller posts are 8 inches longer. So that would be whatever the shorter ones are plus 8. But then where the equation is going to come from is when it goes on and says that the sum of the lengths should be the height of the deck. That is going to give it to me. Should be is like the equal sign, the sum of the lengths. So that means if I took the X and the X plus 8, that's the sum of the lengths, and it should be, which is equal, the height of the deck, which they told me was 92 inches. Okay. Now, there would be an issue if, see, this was in inches and this was in inches. Sometimes things are tricky where they might have it, one of those might be written in feet, and you'd have to be more careful, and you'd have to get everything into the same unit. So here we would have 2x plus 8 is 92. And we could go in and subtract 8 from both sides. And when we do that, we get that 2x would equal, what is that, 84? Okay. And then once we get that, we'll divide by 2 to get what x is. and x would be 42. And you can go back to where you told yourself that that was the length of the shorter post. So 42 inches, and that's the length of the shorter post. If that's all they wanted, if that's all they wanted you to do, then you'd be done. But this one asked us for the length, how long the support posts, plural, should be cut. So then we know x plus 8 would equal 42 plus 8, or 50 inches. And that would be the length of the longer one. Okay. All right, now the last problem I'm going to do with you is one type, a style of problem that we did something similar to this using trial and error. So here we know that this person collected $137 worth of tips, waiting tables. And the tips consisted of just either dollar bills or $5 bills. Either $1 bills or $5 bills. This is kind of like the one where somebody had gift cards that were either $15 or $20, and we knew what the total value was. Okay, it's also like the one where you had a budget of like $110 to get some purchase, like cups or cell phone stands. And we used pretty much a trial and error approach, and I'm going to show that first. So we could do it that way. So here we know that all total she had $137 in tips, and it consisted of just $1 and $5 bills, and we know she had 53 more $1 bills than fives. Okay? And then it says how much of each did she get? So I'm just going to pick something. So I'm going to think maybe she had 10 $5 bills. If she had 10 $5 bills, then I know she had 53 more singles, which would have been 63 $1 bills. So what's the value of all of that? It would be 63 times 1 plus 10 times 5, and 50 plus 63 is 50 and 63 is 113. Okay, 50 and 63, yeah, $113. Okay, so she had more than that. So that makes me want to have more $5 bills. Okay, so what if she had 20 $5 bills? Then she would have to have 53 more, because it said 53 more singles than fives. Then that means she would have had 73 $1 bills. So what would that value be? Well, it'd be 73, which is just $1 bills, so that's $73, plus 20 $5 bills. So that would be 73 plus 100, that would be 173, which is too much. Too little here, so I went higher on the fives, too much here. So I need to go lower. So let me try 15 $5 bills, and then 15 plus 53 would be 68. So then the value would have been 68 plus 15 times 5, which would be 68 and 75, and that would be 130, 143, which is still too much, but just by a little. All right, so let me drop it down. And if I drop it down to, say, 14, then I'm going to need 53 more than that, which would be 67. And I would have the value of that guess would have been 67 plus 14 times 5, which would be 67 plus 70, which would be 137, and that's what it was supposed to be. So it must be this. must be 67 ones and 14 fives would be my answer. Okay. All right, so the approach I just did right there was the trial and error approach. Perfectly good, acceptable way to solve things unless they say use an equation to do it. Okay. So that's the whole point here, is to use an equation. So if I were going to use an equation to do this, what I would do is this. Let me see if I can just get this problem copied, and I'll do it using an equation. Go back up here. Okay, and now I'm going to do the same problem, but I'm going to do it using an equation. Okay. Okay, so now, not trial and error, but using an equation. As we read through the whole thing, we want to know how many of each she got. So we want to know the number of fives, the number of, and the number of ones. Okay, let me just get a brand new page. All right, a little more room here. Okay, so if I were doing that, then the number of fives and the number of ones are the two unknowns. Number of ones, and then I want an expression for the number of fives. All right, so it says that she got 53 more singles than fives. So if I let X be the number of fives, then I know there should be 53 more ones. Okay, so I'm using that to get an expression for the quantities I'm supposed to find, and I want them both to use the same variable. Okay. All right, now we know the total value should be $137. So think about that. If you had, this in the answer we already know, but if you had two fives, wouldn't that be worth $10? Okay. So if I took the number of fives, then if I multiplied by 5, that would give me how many dollars I would have at that point. So my equation's going to come from taking 5 times X. That's how much the $5 bills would be worth. And then adding to that the fact that X plus 3 is the number of ones, and they're only worth $1. So that would be what the ones would be worth, and I know altogether it should be $137. So then I can let the whole problem go and just use my equation solving skills. Distribute the 1, collect the like terms, and just continue solving that equation, and you'll figure out what X is. So now I'm going to subtract 53. And when I do that, I have a 6X left over here. And on the right side, when I subtract 53, I get 84. And then I need to get rid of the 6, so I'm going to divide by 6. And if I do that to one side, I have to do that to the other. And so X turns out to be 6 into 84, which would be 14. And then be careful and make sure you know what that 14 really represents. That's why it's kind of important that you do the setup part. A lot of students don't like to do that writing there, but it really helps you know. So that 14 means 14 fives, right? Because the X was the number of fives. And then you can go on and find the number of ones by taking and adding 53 to that. And that would wind up being 67 ones. And then make sure you put those numbers into the correct spot when Alex is asking you for them.